Good morning, good afternoon, or good evening, all. Welcome to Sprint. We were calling this not conf, but this is really not conf. When it became clear it didn't make sense to host an in-person event this year, we were bummed. Conf is something I always look forward to, and man, am I burned out on Zooms and webinars. So when we decided to go virtual, we knew it couldn't be just another online version of the same old thing. So welcome to the first day of our little experiment, NGINX Sprint. We distilled our conference down to only the best stuff to keep it interesting, engaging, and most importantly, fast, hence Sprint. Again, if you're just joining us, welcome to #NGINX Sprint. And it turns out there's actually some pretty cool perks that came out of this virtual format. One is it's a single track a day. Two, a lot more people can get access and participate. And three, it's free. Downside, I'm really going to miss the conversation at the hotel bar later. Luckily, we were able to bring in the Tech Field Day crew to lead an interactive discussion about what you'll be seeing today. They'll be leading the virtual hallway track, so stay tuned for the live Tech Field Day roundtable after the keynotes today. And you can join the discussion on Twitter at #NGINX Sprint. While you're there, follow @NGINX for agenda updates, exclusive swag giveaways, and get access to engine experts. So let's get this party started. On today's agenda, we have a few of your favorite NGINX product leaders. Sidney Rabsatt will do a quick year in review, plus a peek at the 2021 roadmap. Conf veteran Owen Garrett will break down microservices. John Kuhn provides perspective on SaaS. And we'll hear how we're bringing F5's tried and true security solutions into the NGINX applications from Chris Witeck. You will want to stick around till the end in a couple hours because we have a super awesome guest speaker. If you haven't read the Phoenix Project, this is required reading for anyone who does, thinks about, or uses the term DevOps. Gene Kim will be here to share what he thinks is the current state of DevOps. So that's essentially it. We are sprinting through the next couple hours together. Don't forget to keep an eye on Twitter, maybe tweet that NGINX Sprint selfie, and I will see you there. So now let's get started. The only way we can start an NGINX conference with Gus Robertson. Ready, set, Gus.
Welcome everyone to NGINX Sprint. I really hope you've been staying safe and well. And due, of course, to COVID, we're not doing this event in person. We've held the NGINX Conf for 6 years in a row, but unfortunately, this time we're holding the event as a virtual event. And because it's very different to Conf, we've renamed it and we're calling it NGINX Sprint. This event is obviously virtual in nature, but it's a lot different in terms of focus, much more technical and really focused on trying to build cool stuff with the NGINX technologies. How do we come up with the name Sprint? Well, Sprint is really all about speed, trying to get to your destination quickly with maximum velocity and power. Also, the name really got its roots with agile development, and it's a bit of a nod to our roots there in agile. And of course, speed is now more than ever incredibly important in this digital age that we're all in. You know, we're seeing that over half of consumers now place a higher value on their digital interactions with a company than their physical interactions. And competition is now only an application away. A few developers with a great idea can compete with a company that's, 20, 30,000 people that's been around 40, 50 years. And loyalty to brands is taking a back seat to convenience and experience. In a recent PricewaterhouseCoopers report of 15,000 people over 12 countries, a third of consumers said they would drop a brand they love after a single bad experience. Almost 60% said they would drop a company that they love for multiple bad experiences. So this really impacts the way that we as a community are building and deploying and running applications. So let's dig a little deeper. To win, you really need to bring new capabilities to your apps at speed, and competitive advantage is the key to success here. And so you don't need to just run fast, you need to run faster than your competition. And what we're seeing is that 40% of people are willing to pay more for speed. You know, you see this in things through like logistic companies like FedEx or UPS in terms of packages, but we're now seeing it in our day-to-day lives with things like Uber Eats now offering an additional cost for priority delivery. So your food is delivered first by the driver rather than last of a group of 5 or 6 different deliveries. So speed is how consumers want things. It's part of that convenience and experience, and it has a real business impact Consumer expectations have also changed. They've been set by the large-scale digital companies like Netflix, like Google, like Facebook. They've now set the bar or the expectation level that we all now need to meet. And so regardless of whatever your application infrastructure is, if you have mainframes or legacy apps that you're working with in addition to modern services to build your experiences, there's no patience for spinning wheels, for taking your app down for maintenance windows, for home pages that say, come back later, we're busy. We even have 100-year-old insurance company tell us that their first page load time needs to be exactly the same speed or better than Netflix or Google or Facebook. Otherwise, their consumers drop their app and go do something else. So we're now all being held to the same performance benchmark and metrics as the large-scale web companies. And when, unfortunately and inevitably, things do go wrong, user patience is at an absolute minimum. Brand and reputation are heavily impacted. So you need to adopt speed to reduce mean time to resolution, to limit the possible loss of customers and reputation. And once again, consumers don't care what you're dealing with on the back end and how complex your app is, and whether you had a cloud outage or a CDN went down or a DDoS on API traffic. They just want that Google or Facebook-like experience. And not only that, downtime has a huge impact on both operational cost and revenue. So there's real impact to the business. And consumers are now becoming so dependent on technology. If your application goes down, you impact their ability to drive revenue and their operational cost. Just for example, think if Zoom went down at the moment with the amount of people using Zoom for video conferencing, both with their customers and internally. It has a domino effect on many different customers and users around the world. So what's stopping us running at this speed? Well, we see three things when we talk to our customers. It's the teams, it's the tools, and the technology. So let's dig into each of these. For the teams, it's really about fatigue that we see. And I wanted to touch on this, not just from a technology standpoint, but also given the situation we're in with COVID. If you think of devs as the engine room of your digital experiences, they're trying to run at breakneck speed. They're trying to iterate and deliver new updates and versions of the apps every week, every day, sometimes hourly, sometimes even more often than that. And we have to try and remove obstacles to drive greater efficiency and reduce lethargy within the developer teams. And two things that we've seen. Number one is letting developers deploy at the speed of which they can innovate, which means giving them self-service capabilities to put the right tools in their hands to let them deploy as fast as they can create in real time. And if anything, cloud has proven to us that if you put the right tools in the hands of developers, they can reach this sort of productivity of deploying it as the speed of which creativity is there. And secondly, this may seem less technical, but we're just reducing the amount of meetings, particularly in the world of COVID. We're seeing a multitude of meetings for people, and developers very much get in a zone. And if you make them stop to get into a meeting, it not only stops the flow, but it takes them a significant amount of time to get back in the zone. So reducing meetings can only help increase productivity. So I would recommend thinking twice before setting up an oversight meeting. If we look really at the tools, where we can help increase speed is really around the automation. If developers are your engine room, then transmission is your DevOps and IT ops team, because they really take the power of the engine to the wheels and control the throttle. And so if we dig deeper here, how we give greater speed to the IT ops and DevOps teams, if you think of self-service for the dev teams, for the IT ops teams, it's treating infrastructure as code so that they can match the same speed at which the dev teams are deploying their apps. This way, they can both be synchronized. And many of the customers we talk to think that moving infrastructure to software is the end of the journey. And that's not the case. That's just really moving the problem from one form factor to another. To truly be modern in your approach, you need to deploy infrastructure in real time as you're deploying the code, so they can support the speed of the application development team at the speed at which they're running. The other area that you can help with tools is around the APIs that you build. We see many customers have built APIs using imperative approach. And by doing that, yes, you do give very fine-grained control to people using your infrastructure or your applications. But at the same time, not everybody wants to be that level of expert and doesn't understand the complexities and the timing and process for all these various componentry. By creating declarative APIs, you reduce that complexity and enable a broader use of a broader audience to use your tooling and your application. And that allows them to run obviously at a much faster speed. And we've taken the same approach to the way that we've built our products, such as NGINX Controller. And then finally, technology. And really, to improve speed with technology, it's around taking an adaptive approach. And so if you think about, your dev team as your engine, your DevOps and IT ops team as the transmission, what car are you actually trying to build? What vehicle are you trying to build? You may want a sports car today. You may want an SUV tomorrow. So you need to have technology that evolves as your app needs change. So you may, for example, want to start by building a monolith because that's the fastest path to building your application. But over time, as the application gets more complex or as more users start using the application, you may want to break that into various services. And you may at some point want to take that from on-prem to the cloud, or if it grows to a significant size in the cloud, bring it back on-prem to reduce cost. So having technology that can evolve and adapt, depending on where your application is in its life cycle, is critical. And that, once again, improves speed, that you don't need to change the technology as your application needs change. We'd also talk about how do you make technology more adaptive through managing the tools that you use. In the early stages of building an application, you may grab every tool you can just for this sort of quest for speed at the beginning of building an application. But very quickly, these multitudes of tools actually become a drag on your application and slow you down. They create complexity, they create latency, and quite often they reduce your ability to have end-to-end visibility within your application. So picking technologies that can do multiple roles within your application, that can use single management and control planes, can reduce that complexity and increase the speed at which your application lifecycle over a length of time evolves, as opposed to just at the beginning. And finally, making sure that your applications are not locked into the underlying infrastructure. From my perspective, we've locked our applications into infrastructure from the very beginning of IT, with the days of mainframe to Unix to Windows and Windows Server technology. And now we're in cloud, we're making some of the same mistakes and locking our applications into various cloud providers. And if we really want to be adaptive, we need to be able to move our applications from one cloud provider to another or back to on-prem. And to do that, we can't lock our applications into the underlying infrastructure. We need to make sure that we use tools that abstract that underlying infrastructure, so that as technology evolves, we can take advantage of changes in technology. Just think of the world of virtualization and how quickly that changed to containers. Maybe there's something else coming down the path. We don't want to be locked into whatever that underlying infrastructure is. We want our applications to be able to evolve as the infrastructure evolves, so that we can compete in the market. So these are sort of some three of the areas around teams and tools and technology that we think that customers are really focusing on to try and drive greater speed. So how can we here at NGINX help? Well, a couple of ways. Firstly, NGINX is built on open source technology. And because we're built on open source technology, we're forced to innovate at the speed of the market. Our community demands it. Our community are providing a lot of the capabilities and features that we build into our product. And open source feeds our commercial offerings as well. So by using NGINX open source or even our commercial products, you're getting technology at the speed of which the market is moving and at the speed of innovation. Secondly, through NGINX Unit, we have built a product that manages 7 different, or runtime for 7 different languages, which reduces the complexity of the different tools that you need to run a distributed or microservice or service mesh application. With NGINX App Protect, we've taken the same engine that runs security and the WAF on top of the big IP products and put that on top of NGINX in the lightweight data plane. And with NGINX Plus, you have a single data plane tool that can take many form factors, whether that be a sidecar proxy or a Kubernetes ingress controller. It can be a load balancer. It can be an API gateway. It can be a caching front end or even a media streaming server. And you don't need different tools for every single one of these data planes. A single data plane can do that with a single management tool. So we're reducing the complexity of your environment through the tools that we offer here. And then finally, with NGINX Controller, we're helping you accelerate your time to market. You don't need to be an expert of the NGINX config or NGINX data plane to get the power. We've abstracted that complexity. And so with a simple click of a GUI or a simple API call, you can do really cool stuff like A/B testing or blue-green deployments or certificate management or publishing and deploying APIs. So through our product, we believe that we're really helping our customers reach this speed and velocity that's so important in today's digital age. So now that you've got the engine of the dev team, you've got the transmission of the DevOps or IT ops team, and your application, you know, the chassis or the application you're building, you know, whatever's important to you, we're here to help. You know, we know that every company and every development team is different. We may all be in the same digital storm, but we're all in very different boats. So no matter where you're going or what type of application you're building or what obstacles you're facing in terms of reaching velocity and speed, I wanted to let you know we're here to help and we're here for you. So thank you so much for joining Sprint. Please continue to stay safe and well, and we really hope you enjoy the next few days of content. Thank you very much.
Hello, folks. My name is Sidney Rabsatt. Hello, folks. My name is Sidney Rabsatt. I'm VP of Product Management here at NGINX. I'm going to spend a little bit of time today talking to you about what we've been up to over the past year, as well as what we have in store for next year. As you may have noticed, NGINX was purchased by F5 just about a year ago, just over a year ago. So I'm going to talk a little bit about some of the cool things we've done together. But first, I want to start with a little bit about open source and innovation. You know, when I think about open source technologies, I think about software that sits at the core of interesting applications. It's not the end goal, it's a component of that application. And so when I think about, you know, the foundations that applications and innovation are built on top of, I think about Bedrock. I think about, you know, things like granite. This is a picture of Half Dome. It's a extremely large exposed piece of granite in Yosemite. And, you know, when you think about that type of foundation, you think about, you know, things that are reliable, that are secure, that are commonly available. And NGINX is all of those things. And we actually support a huge number of interesting use cases. We help deliver season finales so that when you're looking at a show you care about and you're about to see that cliffhanger, things don't cut off in the middle and leave you hanging. We assure financial transactions. So we make sure that money gets where it needs to be, down to the last cent. And, you know, more interestingly, recently, we feel great about being able to help folks track pandemics, track, you know, COVID-related information in real time. So we're really proud of all the things that we're able to do as a component of an application. But let me talk a little bit about what we aren't. We're not bloated. NGINX is all about streamlined software. The NGINX code base is about 200,000 lines of code, less than a couple of megabytes. We're not unreliable. We run 450 plus million websites. We're not unsupportable. When folks have trouble, we typically respond in less than 30 minutes. And we're not easily exploitable. Over the past decade, we've had on average less than one major CVE every year. So what is NGINX? NGINX open source specifically is fast and flexible application infrastructure with minimal footprint and maximum value. It goes where you need it to go and does what you need it to do. Part of that is making sure that it supports the most modern protocols and standards and giving you the flexibility to extend it through things like JavaScript, which is one of the fastest performing ways to extend NGINX, through Lua, which is highly extensible, and other dynamic modules in some situations. So who do we build for? Well, there are a few types of folks that tend to leverage NGINX solutions, typically starting with developers, those folks that build modern applications. A huge number of operations folks leverage this too, to help deliver and operate those modern applications. And folks that are doing transformation of their business is typically architects working collaboratively with developers and operations folks to really speed and scale the delivery of modern applications, APIs, and microservices, in addition to driving better collaboration across teams. So when folks tend to think about NGINX, they think about it, I've heard it often described as a Swiss Army knife. It can do a million things. And so for those folks that are building applications, we want to continue to be a tool that can be leveraged to build more interesting things on top of. That's our role as a flexible piece of infrastructure. And so there's a lot of general capabilities we've built into the solution to support modern protocols like HTTP, gRPC, as well as releasing experimental support for HTTP 3. We've made it easier to tie NGINX into your application logic by adding more support for variables when serving applications and sites. And we've extended our JavaScript capabilities to, again, allow for more programmability of our solution as part of your application. On the Kubernetes front, we've done quite a bit of work to make more sophisticated rules available, not only so that you can leverage NGINX for what you want it to do, but also to change the pattern of traffic, whether A/B or circuit breaker related. And we've fleshed out the ecosystem integrations. We've added visibility with open tracing, and we've added support for the latest versions of Red Hat. On the application server side, we've introduced and enhanced our ability to securely deliver a lightweight containerization solution. So we're doing lots of interesting things from a development perspective to help folks that are trying to do new things and break new ground better. So what if you're scaling up? What if you need to not just work on a hobby, but maybe build a house? You need durable infrastructure that you can count on to make sure that that house that you build is on solid foundation and is going to last for a while. And so what we've done here on the operations side of things, this is where we focused on secure delivery of applications, APIs, and microservices. We've added a number of features to make it easier for folks to understand how to route traffic better by allowing them to visually tune the limits that they put on traffic, whether it's rate limits or connection limits. We've given folks more control over how their services are discovered, so that when your application behaves dynamically, we can make sure that we route traffic to it as dynamically as well. And on the security side, we've added some very advanced security capabilities, especially now as part of F5, that really allow you to put the right level of policy and the right level of security in front of your modern applications and microservices, no matter where they are. And finally, as you scale up from a tool to maybe building a house to actually building communities, when you're dealing with lots of applications and lots of teams and lots of services across those teams, you need a scaled solution to securely deliver those applications. And so as part of F5, we upgraded our self-service solution for helping teams collaboratively deliver applications. We brought the best of NGINX together with the best of F5, and we've built an application-centric solution that starts with the ability to give you the analytics, the dashboards, and the alerts that you need to make sure that you understand what your application is doing. But beyond that, we focus on two core use cases today. There's the ADC side of things for modern applications, as well as the API management side of things. So on the ADC side, we've really focused on an application-centric, agile approach that really ties in well with your CI/CD infrastructure via API. And as a bonus, we give you some tools to help eliminate some of those pesky certificate-related issues that folks often run into. On the API management side, we're really excited to finally take a step forward here with a solution that really gives you really user-friendly definition capabilities, the ability to manage different versions of APIs across their lifecycle, giving you core security capabilities to make sure that the content requested and delivered is exactly what it should be. And we've wrapped it all with a nice, clean, new dev portal. So what's in store for this week and beyond? This is where we get a little bit into roadmap. First, for the development side of things, we're building more and more support for modern protocols. We mentioned HTTP2, gRPC, HTTP3. You'll continue to see goodness come from us on those fronts. There will be more ecosystem integrations, and making sure that the ecosystem that we work in and the integrations that we've built all get the love that they need. We're going to be building in richer containerization support. On the operations side, we'll have richer controls for how traffic gets delivered to applications and APIs. We'll be delivering more surgical ways to deliver the right security in the right places in your application or microservices environment. We're going to be delivering simpler and more powerful Kubernetes networking capabilities. And for those that are looking to transform, we're going to be focused on giving folks better decision-making abilities through analytics, better ways to collaborate across multiple teams, simpler management of expert-level security without having to be a security expert, and simpler management of microservices infrastructure for folks that are running highly complex microservices applications. So there's a lot of work that's going on here to bring value to folks across all of these dimensions. And if you note, the things that have asterisks by them will be covered in other keynotes as well as other sessions that we're going to be holding this week. So we look forward to sharing more and more information with you folks. And with that, I will bring this to a close and say thank you and take care.
Thanks, Sidney. That was a great overview of everything across NGINX. And now we're going to bring this a little closer to home with a demonstration. My name is Brian Ehlert. I'm a technical product manager with the NGINX Controller product team. NGINX Controller is a platform to bring together your teams and their workflows in the context of their overlapping interests and responsibilities. It is built with you, the customer, in mind and how you do things. It gives everyone a way to safely share in your ever-growing fleet of NGINX instances, all around the notions of self-service, application centricity, and automation. Regardless of the use cases or how you use NGINX, Controller is the place where we start to bring it all together. If your needs are for insights, it offers built-in analytics. If your needs are to manage complex reverse proxy rule sets with ever-growing needs for advanced application delivery controller functionality, we give you safety around configuration management across your NGINX instances. If your needs are for extending and presenting and securing APIs, we offer API management. And for those of you that are working on your very modern applications and using technologies such as Kubernetes Ingress Controller or Service Mesh, we'll be offering features for you. NGINX Controller gives you the power to manage your NGINX fleet safely and securely with an application focus. It gives you an API and a definition pattern that's easy to understand and easy to segment across your workflows and responsibilities, as well as to drop into your automation. And best of all, it makes it easy to offer self-service to your internal teams, giving you safety through both role-based access control and the safety around configuration management, where you might have multiple people impacting the configurations of single NGINX instances. So now we're going to set up a demonstration scenario. For that, I'm going to move over to NGINX Controller. This is an environment that's been running for a while. Imagine that it belongs to you. So your operations team has come into Controller and they've set up some services. They've set up multiple environments for you to work in. In this case, there's two. We've got a production environment and we've got a development environment. We have gateways that reside in those environments, and they're serving applications for us. Behind these gateways are actually the instances that our customers are touching. So this is where our traffic is coming in direct from your customers, and they're touching this first level of these gateways. So they might be serving up APIs for them. We might be providing advanced application delivery controller functionality for them. But this is that first level of routing. Behind here, we have applications. And applications are a logical way to divide up that pretty much mirrors how many customers act within their environments. So we've got a service center, a rate calculator, a mortgage application, and our base application. Behind these applications, we also have the notions of components. So we know that applications don't exist in a vacuum, and they're not big monolithic things anymore. Even monolithic applications aren't necessarily monolithic. Behind them, we've got different components that make them up. And in modern applications, we have different teams that are responsible for different components. So we want to make sure that we mirror those things within our configurations. There's also some certificates here that are available for you to reference and use. So your certificate team can take care of managing these certificates, and you don't have to concern yourself with it. So what we're going to do is we have a configuration that we have all set up, and this is just a single component. This is the careers component that we're going to be working with, and I'm going to make a configuration change to this component. So where today we're focusing on these two workloads on the back end, we're going to change this configuration just a little bit. We're going to extend it with an application that, well, it's a new version. We're pretty confident that this works pretty well. It's gone through all of our testing, and we want to put it out in production so we can take a look at what it is. we're going to put some weights on here because we don't want to send all the traffic to it. We don't want to just put it right out there right away. So we're going to check this in, and we're going to do test the new version. And I'm going to go ahead and commit that. And after that's committed, I'm going to go ahead and push this up to repository. So what's going to happen now is my push to source control is going to trigger a webhook over an Ansible tower. These jobs are going to run, and they're going to move that configuration into controller. Controller is going to test those configurations, make sure there's no conflicts between the various teams, and it's going to go ahead and push those out to the NGINX instances for me. Now, those changes are in production. So if I come down here to this application for the main www site, and I take a look at the career site, which I just applied to the configuration to, I can see that in my workload groups, I now have 4 servers sitting here, that they're all in production. I can start to take a look at some of the information that's available for those instances. We can look at the latency, and you can see right here I did the push, and oh my, something's not right. And I've just got a small trickle of traffic over there, but there's a latency problem here. So before I go drilling into it, I want to show you something about the power of this data. So something else that your team did. They set up an integration with Datadog, and you've got a key performance indicator metrics that you're actually running over here in Datadog. So you can get a really quick view on what's going on. But all that environment and application and component and gateway and instance and workload, all those logical components are coming over here with the data as well. So we can start to take a look, and we can quickly come down into this careers component that we impacted. And you can quickly see the spike that we have that's going on here in performance. And this is a response latency on that path that we just enabled. So we better go in and do something about that. So we're going to come back over here, and I actually want to leave that into production. So I want to change the weighting on that. I want to make sure we get most of our customers running over into production, and I want to make sure that only a trickle is over here because I want some time to look at this. I need to figure out what the real problem is behind this. So I'm going to reduce the load on that. I'm going to go ahead and check that in, and I'm going to push that configuration over. So I'm just going to synchronize that. My workflow is going to take care of all the rest. Now, in the meantime, you might be wondering what else is going on with our application. So, we've got other teams that are going on. So if I go ahead and I come back up here, you might have noticed earlier on that, there's this other latency problem that's over here. So I've got a different team on the same site that's been working here on this index problem the whole time. And they're doing that. They're working on there safely. That's a different component. So they can make their changes to that. They can work on that component separately from my component, even though we're within the same application, even though we're impacting the same NGINX instances in the end. And they can safely make all the changes that they need to make while I'm safely making all the changes that I need to make. And it's all self-service. Like I say, we've divided this up according to our roles and responsibilities here. Any certificates that we've needed in here, they're just referenced and they're pulled in, they're applied to the instances. We can take care of that lifecycle separately as we need to. We get quick views into the metrics that are going on here, the latency metrics, and there's even views here that are not application-centric. So if you're used to more of this infrastructure type of view, we actually have these views as well that we offer you. So we give you a whole host of different things that you can look at. Now, just to give you that quick view of what's going on with NGINX, go ahead, and if you want to take a look at controller, go to nginx.com, whack controller, and request your free trial. Take a look at NGINX controller out of the box, take a look at what you can do there, and continue to follow through with the sessions and learn more about everything that NGINX has to offer across the whole breadth of products.
Hello, and welcome to our session on introducing the NGINX Service Mesh. My name's Owen Garrett, Senior Director of Products in the NGINX Business Unit at F5 Networks, and it's my pleasure today to share with you the plans that we have bringing us up towards the first open beta and general availability of our new NGINX-based Service Mesh solution. We're living in unprecedented times. And no, I'm not referring to the COVID pandemic or the Black Lives Matter movement or any of the other hugely significant geopolitical changes that we're living under at the moment. There's some good, entirely positive news too. In our industry, the industry of creating and delivering applications that support our organizations, that enable people to connect, to communicate, and to conduct business, we are making immense strides. Huge strides in the form of developer productivity, of innovation, and time to market. To delve into this, we need look no further than GitHub's Octoverse report. They've seen from their own activity that the number of developers on GitHub over the last year has grown significantly, adding 10 million new developers in 2019. The rate of repositories that are being created, particularly by those created by developers for the first time, is huge. Pull requests show the active repositories, the activity that developers and engineers have. 28% more developers opened their first pull request on GitHub last year than the year before. And the rate of closing issues is a great indicator of the quality, the innovation, and the rate of improving software. Behind this is continued adoption of high-level languages, of opinionated application frameworks that help developers focus on the problem at hand without having to worry about the infrastructure. Practices such as agile development, tools such as low-code or serverless that take a lot of the burden away from developers. Even platforms and application servers such as NGINX Unit all contribute to improving developer productivity. And the net result is not measured in lines of code or defects per thousand. The net result is that the speed at which businesses deliver innovation is accelerating. The speed at which businesses can bring new applications and services to market is reducing significantly. A very important change that's helped to drive this has been the widespread practice of uncoupling large, complicated applications, monoliths if you like, into smaller, decoupled, independently developed, independently designed, independently tested, and independently deployed components. Microservices and containers have emerged as building blocks for this new style of building and operating applications. And the two are very often paired together, even though they are independent, autonomous technologies or approaches. And Kubernetes is emerging as the standard for managing microservice containerized applications at scale. How do we know this? Well, from our own surveys, when F5 surveyed their enterprise user base, they saw a shift last year. For the first ever time, more organizations chose containers as their preferred deployment platform over virtual machines or virtual appliances. And in the NGINX survey of our user base, almost half of NGINX commercial users who used NGINX Plus to deliver their applications, were running Kubernetes in production. But of course, the reality is much more complex than a simple shift from a monolith to a microservice. Containers, microservices, Kubernetes are strategically important, but organizations also operate traditional assets that are difficult or maybe even impossible to put through this modernization cycle. The quality of a modern application is that it's hybrid, it's disaggregated. Components may run in a monolithic fashion, on an application server or in a virtual machine. New components may be delivered in a microservice fashion on a Kubernetes cluster, but very often additional components and extensions are done using a strangler-like pattern to wrap existing applications. So we see complex, disaggregated, cloud-native patterns running alongside traditional classic monolithic patterns. We see multiple consumption models. We see everything being automatable. And it's this complexity that underlines how modern applications are structured, are architected, and delivered. This complexity inevitably brings a number of operational challenges. We have seen through our own research a significant increase on the number of attacks on applications over the last 2 years, as malicious users and entities attempt to exploit vulnerabilities in the operation or the behavior of applications. And at the same time, with faster development cycles, faster code to production cycles, it becomes increasingly hard to put proper, trusted, secure processes in place to ensure the security of an application. We've seen 100% of the organizations we spoke to identifying that they lack adequate visibility into the performance, the health, and the availability of their applications and services. And that's compounded by the complexity and the number of different components that support those applications. That complexity also brings operational challenges as different styles of applications, as different language frameworks, as different application servers, as different deployment patterns are running in parallel. And these complexities are particularly acute when we look at Kubernetes-based, container-based microservice applications. You need look no further than the CNCF landscape to see the huge growth in tooling and best practices that attempt to address some of these complexities for applications that are written in a cloud-native fashion, targeting Kubernetes and similar environments. One such technology that is emerging to address some of these operational challenges is the service mesh. A service mesh, at least from NGINX's perspective, attempts to address 3 critical operational challenges for applications that are distributed and are running on environments such as Kubernetes. The first challenge that the service mesh attempts to address is that of securing the application, allowing it to run in a shared container environment where there is a zero trust network, and layering the necessary security on top so that individual components of the application can only talk to components they're authorized to, and all intra-component traffic is secured and encrypted using practices such as mutual TLS. The second challenge centers around observability, measurability, visibility of traffic. No longer can you attach a debugger to an application and trace calls to functions to help understand how the application is behaving and identify failures. When the application is spread across multiple different components that may scale up and down autonomously without warning, then debugging and troubleshooting applications takes an entirely new scale. And the service mesh attempts to layer transparently the ability to instrument and to troubleshoot calls between different services in an application. And finally, in a world where individual components are developed in parallel, deployed and scaled in parallel, the task of operating and managing the traffic within that distributed application becomes immense. These are all capabilities that Kubernetes has core primitives to address. But in a modern, complex, sophisticated environment, those capabilities often do not go far enough, are not fine-grained enough, or granular enough. And so a service mesh allows a developer to specify policies that attach to individual requests or transactions and implement things such as load balancing or circuit breakers to protect vulnerable components of an application, or to switch and route traffic with practices such as blue-green and A/B testing. Behind these capabilities is a critical design goal, and one that made early mesh implementations very difficult to deploy and operate. A design goal of transparent orchestration, automatically injecting the necessary components into the infrastructure and application to provide the level of control that was needed, and interfacing with the APIs or tools that users used to manage those applications in a seamless fashion. And so I'd like now to share with you the work that we have been doing to build a service mesh implementation based on an NGINX-based proxy. As we've done this, the work has been guided by the core principles and qualities that have served NGINX very well for the last 15 or 20 years. The qualities of being lightweight, of providing the highest possible performance in terms of throughput and lowest latency, and the qualities of being simple and perfectly formed for the task at hand. As we go through the architecture of the NGINX service mesh, let's begin with a classic Kubernetes environment. Kubernetes at the infrastructure layer and a control plane comprised of the Kubernetes service registry and other components, and an API wrapping that registry. When you come to deploy an application on Kubernetes, you'll deploy it as a collection of services, each made up of pods, perhaps a different number of services within each pod, and almost inevitably an ingress controller in front of that application, bridging the network and handling north-south traffic as it comes in to the Kubernetes environment. Our goal, of course, is to gain control of the traffic between these individual services so that we can then layer on the capabilities of security, observability, and traffic control. And that's done through the automatic and silent injection of NGINX-based service mesh proxies into each of the containers that makes up the nominated application. The proxies take control both of traffic coming into the application, ingress traffic, and egress traffic coming out of the application or services. And in addition, we layer on an additional incarnation of the NGINX ingress controller, this time repurposed to handle egress traffic. With these points of control, we now have full control over traffic coming into the environment, being delivered to an individual service or pod, coming out of that service or pod to another service or pod, and ultimately requests that may need to go back out of that environment to external services that must be consumed by the application. All of these capabilities give us the level of control that we need, but they don't address the biggest single challenge that the service mesh must overcome, which is that applications are fluid. They can scale and contract without notice. They can talk to external services that can appear or disappear without notice. And as we wish to apply policies to the traffic that flows through that application, those policies can change the nature of the topology of the application and the traffic meshing requirements of the mesh. And so to meet that, it's necessary to layer an additional control plane into the service mesh to hold the topology of the application, to hold the policies that govern how traffic is managed and routed within that application, to learn from the Kubernetes inventory as to where components are deployed, and then to interface with the individual control proxies, both the NGINX ingress and egress controllers and the NGINX service mesh proxies running within each individual container. When we set about designing the control plane, we took the approach of building what you might regard as a sidecar control plane. It was very important to us that we did not pollute the existing Kubernetes service registry with our own configuration. We wanted to build a control plane that could be scaled and deployed independently of the Kubernetes service registry, and potentially in the future also deployed outside of Kubernetes. We wanted to build something that was lightweight, perfectly formed, and critically importantly, could be uninstalled as easy as it could be installed into the environment, thus reducing the risk and the complexity of deploying the NGINX service mesh running it through test and evaluation processes, knowing that if it didn't meet requirements, or if a large-scale redeploy was required, then that would be easy to do without disrupting the existing Kubernetes environment. In fact, you can enable NGINX Service Mesh in a Kubernetes environment, deploy applications which will automatically inject sidecars, deploy policies, perform all of the service mesh capabilities, and should you need, you can then pull the service mesh out of the environment, removing the control plane and leaving the proxies inside individual containers running in very, very simple pass-through mode, making the task of deploying and removing the service mesh as simple as it could possibly be. In order to provide mutual TLS security for the communications between the individual components in the application, we've used the Spire framework with Spiffy to distribute certificates and implement mutual TLS for traffic between the ingress and egress controllers and the individual service mesh proxies. We provide a simple default install of Grafana and of open tracing within the service mesh deployment. Of course, it can very easily be pulled out and you can replace that or point it towards your existing infrastructure tools. This provides the observability and the debugging necessary to control how the application, to observe how the application is operating. Looking at the timeline for the NGINX Service Mesh, we will announce an open beta of the mesh with a target date of the end of September 2020. And then this will take us through a period of in-production testing and hardening and feedback towards a target general availability date of the end of 2020 or early 2021. Within that open beta and GA release, you'll find a fully autonomous control plane with automatic integration with Kubernetes, auto injection of the data plane components within individual containers. You'll find security management capabilities. So building on the Spiffy and Spire projects, certificates can be issued, revoked and expired. Mutual TLS will be implemented between every individual component of the application, and firewalling will allow you to run in a zero trust environment where other services managed by other parties are running on the same Kubernetes environment. Integration between both the ingress and egress controllers and the service mesh through a single consistent API, so integrated north-south and east-west traffic management, will deliver operational efficiencies. With a single API and a single observability interface, you will be able to configure, secure, and tune how traffic comes into the Kubernetes environment, how it's distributed across the forward-facing endpoints of the composite application, how it's then spread across the application in an east-west fashion, and control for any calls, API calls, or HTTP requests that need to be routed out of the Kubernetes environment to external services. The SMI spec provided the core design and inspiration for the way that we distribute and control how traffic is split and routed, and the way that we observe and provide metrics for traffic. So with an SMI spec compliant implementation, the service mesh will help you in an operational environment to deploy new instances of a service and move traffic across in a blue-green fashion, to prove new instances with A/B testing, to implement canary testing for an initial instance, circuit breaker patterns to wrap an instance with a default response and protect that instance from being overloaded in the event of a failure, and to implement targeted rate limiting, again, protecting or controlling how much resource individual services or requests can consume. Metrics and observability will interface with standard Kubernetes and CNCF tooling, such as Prometheus and Open Tracing, to give you traces, metrics, and observability instrumentation to identify the performance, the bottlenecks, and to troubleshoot individual services. We have a goal of broad platform support. We're actively testing the service mesh implementation on both hosted Kubernetes platforms, on-premise and third-party platforms. And with everything coming through the Kubernetes API, that helps you have a standard management interface for not just the mesh configuration, but everything else which you're already doing against Kubernetes. As we look towards the futures, as we go through the hardening period of 0.6, the general availability and the availability of a supported service mesh with a target of the end of 2020 or start of 2021, then we look towards additional capabilities to extend the mesh beyond Kubernetes to endpoints of the application that are not just accessible through the egress proxy, but rather can be reached directly through the mesh to an endpoint outside of Kubernetes. Supporting additional protocols, UDP-based protocols, for example, so that the mesh can handle traffic such as DNS or media delivery. Configuration that also addresses the challenge of taking an API specification, so a Swagger or an OAS specification, and converting that into rules that should be pushed into the service mesh. And taking advantage of the additional capabilities that you find in the NGINX proxy. The proxy, the data plane, is far from being a simple packet pusher. With NGINX, we have capabilities for request-based authentication, security policies, advanced WAF, rate limiting, and all of those could be tactically targeted into a mesh-based deployment. For example, by deploying WAF rules at the edge for ingress traffic, so that any traffic coming into the mesh environment has been scrubbed and secured. And further in the future, there are immense opportunities to take the mesh technology and to make that manageable and visible through the NGINX control plane. A mesh is by far the only thing that you need to deploy an application. As you think about the delivery pipeline for that application, you've got to think about application delivery, so ADC, load balancing, API management, API policies, and security policies, in addition to the capabilities delivered by the mesh. And the goal that we hold high is that NGINX Controller will be able to give you a single API-driven configuration layer that can manage and monitor and visualize and trace all of the critical services that are necessary to deliver a modern enterprise application. And finally, there's huge promise as we look at the capabilities within NGINX Unit. An open source application server with its own built-in proxy and the ability to run multiple instances of an application and to scale them running different applications concurrently on the same footprint. Where we could configure and manage Unit through the mesh, then that introduces a lot of exciting new possibilities to change the way that applications can be packaged and deployed and scaled. And this is an active area of research within the NGINX product group. So I'd like to thank you for your time today. I've shared with you a taster of what we will be releasing later this year in the form of an open beta of the NGINX service mesh, working towards a fully supported production-grade mesh at the end of this year or the start of next year. And with an ambitious future roadmap and a clear vision on how we can take that mesh technology and fold it into additional NGINX estate and NGINX control plane tools to produce a rich, automatic, adaptive, scalable interface for deploying, managing, and delivering applications. So please, follow us on nginx.com, watch out for the future notifications on availability of the mesh, and I look forward to catching up with you, whether it be through GitHub issues or webinars or briefings that we can do to share with you what's coming in the future with NGINX Mesh.
Welcome to the session, NGINX Application Security. My name is Chris Witeck. I'm a Director of Product Management here at NGINX. And I've been at NGINX for a few years, really since the acquisition of NGINX by F5. And as mentioned, today's session is going to cover NGINX Application Security. And we're going to start with what are some of the challenges that we see our customers facing when they secure modern applications? And then we're going to jump into how can NGINX help those challenges. First, by talking about the security options available for NGINX Plus, and then by ending with the security options available with NGINX Controller. So let's dive right into it. So let's start with talking about what are some of the challenges that we see customers facing when it comes to securing modern applications. This can be a broad topic. This is something we can talk about for a lot longer than 15 minutes. What I'm going to do is I'm going to cover some of the highlights, some of the key elements that we see from customers. One of the first challenges relates to how you layer security into your pipelines. Many of the security tools we see our customers using were created for fixed perimeters with just a few connections to secure. And often customers have tried to evolve their security approach by leveraging these exact same tools, yet these tools were not built for that task. This is challenging because dev pipelines today are built for speed, not for security. Many security tools are not keeping up with modernizing operation models. Inserting security into modern dev pipelines means relying on automation, yet many legacy tools are not designed for automation. Additionally, security teams will be the first to tell you they have a hard time finding and staffing people who really understand security and code, which adds challenges with layering security into your pipeline. Another challenge is the fact that how organizations are modernizing these applications. Many customers today are transforming how they build and manage applications, leveraging many different types of environments. This can lead to challenges to understanding the unique security requirements each of these environments may have. One area is the confusion on who owns security in a cloud environment. Many organizations often misinterpret the role of the cloud provider. They assume the cloud provider is taking on more responsibility for security than they actually are. This has led to scenarios where cloud infrastructure is not kept up to date with security updates and patches. Additionally, today's modern applications are really a collection of services interacting with each other via APIs. And these services can exist anywhere, with data flowing between containers, between users, between devices, and different types of environments. Where with a monolithic application, you may just have a few self-contained services. Services for modern applications can be located anywhere, using all kinds of different technologies. This can make it very hard to understand where a modern application starts and where it stops, creating a very large attack surface that you have to defend. Network infrastructure teams and security teams, they have a lot of experience with securing on-prem infrastructure. But as workloads and applications shift to cloud environments, in many cases, the DevOps or the app dev team within the organization have taken on responsibility for adding security into those environments. Securing this expanded service can be very challenging for overburdened security teams, and friction between the various DevOps teams and security teams can lead to dev teams attempting to work around security requirements for the sake of speed. This is an example of that shadow IT challenge. There's many examples of shadow IT, but in this case, we see oftentimes development teams trying to work around the security teams for the sake of speed and for the sake of agility. But that creates challenges for the organization as a whole in making sure that they are compliant with security requirements. The last challenge I'll mention is really a kind of a summary of this first three. Many organizations attempt to secure this expanded perimeter by throwing too many tools, too many security layers, and too many manual processes that can interrupt development pipelines. This can impact application performance. It can impact visibility as security teams attempt to aggregate, consolidate, and correlate data from multiple sources, and can encourage security to not practically be applied. The result is frustration and friction, with both DevOps teams and security teams having a hard time determining what is normal and what is abnormal across all the applications they are asked to secure. So what are some of the things that you can do to help address these security challenges? Well, first, you can invest in lightweight and agile security controls specific for your modern applications. Look for tools that can be embedded by your DevOps teams into your pipeline using automation. You will never have enough security people to throw at security, so automation is your friend. You can also segment or compartmentalize your microservices and container environments so that you can apply security controls to each segment, with some sort of logical ingress point serving as a control point for that segment. This implies a much different trust model than legacy network security, but it also allows you to apply more effective security that was possible with monolithic applications. If security for a monolithic app fails, the entire app might be compromised. But if security for a specific segment fails, and your security controls prevent that attack from spreading to additional segments, you now have a much smaller blast radius that you have to worry about. And lastly, keep an eye on performance. There's a tendency in security sometimes to layer in many different security tools. This is not to say that defense and depth protection is not a worthy goal, but selecting the wrong security tool and then layering on another tool on top of that because you're not happy with that first tool, before you know it, performance of your application starts to suffer. So what is NGINX doing? What are the NGINX investments that we are making to help add and layer in security for modern applications? Well, we are investing in security solutions that can be invested by DevOps teams and SecOps teams and used within your pipeline. Solutions that make it easier to secure apps in a wide range of environments without having to trade off performance for security. Our goal is providing your security teams choices and flexibility on where to deploy security services. Your DevOps teams can deploy services specific to an application, shifting security to the application itself, whereas your network teams and SecOps teams also have choices for securing infrastructure and groups of applications. What we are doing, and our goal is to provide security teams with the ability to provide development teams with guardrails and guidance. This is something we hear consistently from DevOps teams within our customers. What they want is guardrails, not gates, from their security counterparts. Meaning, provide the appropriate guidance and tooling to insert security into the pipeline versus dropping some sort of gate that interrupts development anytime a security review or a conversation needs to happen. So let's talk about some of the specific investments we're making. When we talk about the NGINX portfolio, we talk about it in broad terms as two different layers. Layer one is the data plane, represented by NGINX Open Source and NGINX Plus. Layer two is the control plane, represented by NGINX Controller. We are investing in application security specific for each layer. Security for the data path is optimized for customers managing their underlying infrastructure directly, allowing customers to build in very specific security depending on how they're leveraging the data path and the services contained within that data path. Security for the control plane is optimized for specific use cases that the controller represents, simplifying how security is inserted into that use case. For example, providing security for the delivery of a specific application. We'll go into detail on security options for each of those layers throughout the rest of the presentation. So let's start with NGINX Plus application security. So NGINX Plus is ideal for organizations building out a fit-for-purpose data plane aligned to the specific application services contained within that data plane. And oftentimes we see customers building in their own targeted control plane with fit-for-purpose automation and orchestration. For this audience, we are layering security in the form of the recently released NGINX App Protect, which layers in security for the main NGINX Plus use cases that we see from our customers. That's where you're using NGINX Plus for an application or a web server, or as an ingress controller, or as an API gateway, or maybe as a load balancer. You have the option with NGINX App Protect to layer in security for each of these application services. How does NGINX Plus work? And how does NGINX App Protect work? NGINX App Protect is a lightweight web application firewall that's based on F5 technology that allows customers to shift application protection closer to the apps and application infrastructure. What it provides customers is a strong and high-performing security tool with trusted signatures from F5, backed by F5 support. But this is not a port of a legacy F5 security tool. This is a completely new solution designed from the ground up for how our customers are building and deploying their applications. App Protect is deployed as a lightweight module designed for NGINX Plus and the environments NGINX Plus supports. What this provides you is a tool that allows you to insert security policy as code with easy integration into your CI/CD pipeline. And App Protect can be deployed in a wide variety of different options. First and foremost, it can be deployed at the edge, at the network edge, with an edge load balancer, probably one of the more common use cases. But as you start to shift security more towards your application environments, there are additional options as well. It can be deployed with an ingress controller, where NGINX App Protect works with the NGINX ingress controller. It can also be deployed to specific services within the Kubernetes container. And then lastly, it can be tightly coupled with an application where App Protect is implemented as an embedded proxy for each application prod. The point is, you have a variety of different options in how you can deploy NGINX App Protect with security applied more closely to your application or more closely to your infrastructure. The choice is yours. NGINX App Protect was first released back in May with the core offering designed around things like OWASP Top 10 support, regular attack signatures from F5, and covering some of the API security use cases. We continue to release on an agile basis with some of the recent releases, including things like threat campaign feeds, which is a moderated set of signatures to improve security efficacy, and also additional enhancements that allow you to set more stricter security policies, so more granulated security on an as-needed basis. So that's information about NGINX App Protect. Now let's shift gears and talk about NGINX Controller application security. So NGINX Controller provides customers with an easier approach to enabling application services by providing a standardized way to how you can manage and deploy applications that can be deployed by your development teams and DevOps teams across a large and distributed enterprise. With controller application security, we're taking NGINX App Protect and inserting it into the controller story. First covering the ADC use case and then adding it into API management later on. The controller application security offering, it's going to start as an add-in module for the ADC use case. And it's available in beta now with commercial availability coming in the fall. And the main use cases we're covering is as follows. The first is allowing you to insert security policy lifecycle management into the deployment of your applications. And we're doing that by allowing you on a per application basis and a per component, so it's even the specific ingredients of your applications to enable security for each application component, leveraging NGINX App Protect, which we just discussed as the enforcement engine. But there is additional value on top of that. Second area of value relates to the security insights that controller application security provides. An easy way to see that insight is through the security dashboards that are very much specific to applications. One of the main value stories of controller is allowing you to set policies on a per application basis. That extends to security. So you'll be able to see on a per application basis security and the impact of security on application performance. Your DevOps teams can have a per application view for the applications they manage, and the security teams can see security impact across all the applications in use across the enterprise. This really allows you, your security teams, and your DevOps teams to see how security is impacting traffic to the application, as well as impact of security to the overall application performance. The third area of value is related to how controller enables developers and DevOps teams to add security to their applications in a self-service manner. So an example relates with what we just described. Your DevOps teams can see what applications they have specific permission to manage, and they can insert security just for those applications and just for the application components. So just the pieces of the app that they're responsible for. And then separately, your security teams can have their own view that looks across the entire organization, provides them with that ability, as we talked about before, to set those guardrails, those security guardrails, based on application risk and application use case related to all the applications in use by the organization. That relates to our goal to provide the ability to align security policies to applications automatically, leveraging those preset guardrails set by security. We want the DevOps teams to be empowered by security to easily and effectively layer security into their applications without having to pause their pipeline and to engage the security teams directly. And combined with the intelligent insights we just described, we want the security teams to be able to audit and have the necessary visibility for how security is applied to each application across the entire organization. So in summary, Controller enables organizations to deploy app protection easily in a standardized manner and with self-service capabilities extended out to the various app teams, but security still maintaining the control and visibility that they need. So that was quite a lot of information in a short amount of time. I just want to wrap with an overall summary of the security offerings available from NGINX. And one thing we did not discuss was mod security. Mod security is a great open source security tool that a lot of our customers use with NGINX open source. And we also sell a supported version of mod security with NGINX Plus. That is still available today, and we plan to continue to offer this for quite a long time. Where mod security is great is for simple, more basic checkbox security. It starts to run into issues for high-performing applications or applications where we have greater security requirements and greater security compliance requirements. That's where NGINX App Protect, which we just described, fits in perfectly. NGINX App Protect has been available since May. But if you also want to have that model, self-service model, where you extend security out to different development teams, you want a lot of controls and how those development teams layer security into their applications. So you're a large enterprise and you have large sets of applications that you're managing. That's where NGINX Controller fits in, that we just described. NGINX Controller is available in beta now and will be available for purchase later this year. That was a great amount of information in a short amount of time. If you want to learn more, you can request a free trial of NGINX App Protect at nginx.com, as well as learn more information there. Same thing with NGINX Controller. NGINX Controller, you can go there today and get a trial of NGINX Controller today. As I mentioned, the application security pieces of Controller are in beta, but once you have a trial of Controller, you can engage your NGINX sales rep, and they can fill you in details on how you can take part of that AppSec Controller beta. Thank you.
Wow, that was awesome. It is so valuable to hear the vision and then get to see it in action. But we're going to take a quick 5-minute intermission now. So go grab a coffee or a cocktail or stick around. We're going to do a little yoga sesh.
Hi, everyone. Hope you're all having a great day here at NGINX Sprint. Right now we have a 5-minute break. And just to introduce myself, my name is Leah Marie Dandan. I am a part of the strategic business development team here in the NGINX business unit with F5. I'm also a certified yoga instructor. So today I have the privilege of leading you through a 5-minute yoga session where we'll go through some deep breathing and gentle movement. For today's practice, you won't need a yoga mat, but if you do, you can get it right away and make sure that you're in comfortable clothes. Let's meet in a sitting position. You can be in a cross-legged position or sitting with your feet planted on the floor in your office chair. You can place your hand on your lap, facing down to ground yourself or facing up to receive. Take a couple deep breaths. Take an inhale. Exhale audibly through your mouth. Take a big inhale again. Exhale out of your mouth. Place your left hand on your heart and your right hand on your belly. And notice your heart beating and your belly rising. Relax your shoulders, relax your jaw, relax your belly. Inhale to fill your lungs. Exhale, let it go. Release your hands. Place your right arm on the left side of your head and gently pull to the right side of your body. Feel that nice release on the left side of your neck. Take an inhale. Exhale, rotate your head towards your underarm for an added stretch. Breathe on your own here. Release your right arm. Place your left hand on the right side of your head and gently pull towards the left side of your body. Take an inhale. Exhale, rotate your head towards your underarm and let it go. You may release your hands. Now place your right arm over your left hand to stretch your triceps as well as your shoulders. Relax your shoulders and feel that nice stretch on your shoulders and your triceps, and you may rotate your wrists and your hands from all that typing today. Take a couple more deep breaths. Exhale, switch your left hand over your right arm. Feel that nice stretch on your left shoulder and left tricep. Rotate your wrists and your arms and your fingertips for some added blood circulation. Perfect. Now let's meet in a standing position. You can rotate your shoulders towards the back. Do some shoulder rolls to release any tension. Stand your feet, shoulders and hips width apart, and bring your arms up to the top into mountain pose. Rotate your pinkies towards the back of the room. Retract and depress your scapula. Relax your shoulders. Send your navel towards your spine. Take an inhale here. Exhale, forward fold. Send your weight towards the front of the room by folding forward. Have a gentle micro bend in your knees to release your lower back. Drop your head towards the back of the room and let your body hang heavy. Inhale, halfway lift. Place your hand on your shins or your thighs, wherever it feels comfortable to you, and send your head towards the front of the room. Keep your back nice and flat. Take an inhale here, and exhale, let it go. Forward fold. Take an inhale to mountain pose. Exhale, baby back bend. Retract your arms towards a 90-degree position and look towards the front of the room. Send your chest towards the front of the room. Retract and depress your scapula. Relax your shoulder blades and feel that nice stretch in your chest. Inhale, mountain pose. Exhale, forward fold. Inhale, halfway lift. Exhale, forward fold. We'll do that one more time. Inhale, mountain pose. Exhale, baby back bend. Inhale, mountain pose. And exhale, forward fold. Inhale, halfway lift. Exhale, forward fold. Inhale, mountain pose again. And exhale, place your hand towards your heart, Samasthiti. This is where you can set your intention for the rest of the day. I offer you the intention of gratitude. Be grateful for the resources that you have today. Be grateful for all the colleagues and peers that you get to interact with, and take a break from your day-to-day routine. I hope that you all enjoyed today's quick yoga session. I hope that you all enjoy the rest of Sprint today. Keep yourself hydrated and remember to be kind to yourself. Thank you.
Hi, my name is John Kuhn, and I'm VP of Product Management at NGINX. I'm part of an exciting new expansion for NGINX called NGINX SaaS Solutions. I want to, in this presentation, explore what those SaaS solutions are and what we're doing about it in the future. To start that conversation, I'd like to maybe draw a parallel into the connected home. This is an area that I'm personally very familiar with, as I like a lot of gadgets in my home. And the connected home is really helping us change the way we experience life. It's piping in the right music into the right rooms. It's making shopping easier. It's helping to do more efficient things like turn on and off lights. But there's a whole new potential out there for the connected home and connecting to internet services. And I imagine a day where your alarm clock is set automatically by your schedule. And that schedule has informed the alarm clock to go off at a certain time, but it's also connected to an ecosystem where it's now telling your mattress to heat up to a certain number of degrees before the alarm clock goes off. And once it does, it turns on the shower to nudge you out of bed and start your day. It's also looked at the weather and it's been able to connect to the electric car. It's in your garage and it's warmed that up to a certain level. And when you're on your way and you come home, you see a drone just leaving your house and it's dropped off a box. And you look in that box and it's vitamin C, because when you were looking in the mirror that morning, a camera was filming you and kind of noticed that you might need some more vitamins. So it automatically made that call and dropped some helpful vitamins out to you. There's just limitless potential there. And just as those interactions, with internet services are really making life better in our homes and will do so in the future, that's really the goal of NGINX as a service, is to make your NGINX deployment and the modern apps and digital experiences you're creating smarter, safer, more efficient, and really more connected than ever before. Our goal and mission is to deliver cloud-native SaaS solutions that enhance the delivery of those applications you are creating, those environments that host those applications, and really ultimately make the digital experiences of your customers better. Now, how we're doing that is we want to unlock the value of the cloud for anyone using NGINX. And we're doing that by being able to adapt those services to any environment you're creating, even modern container environments, service mesh environments, where you're doing a lot of complex creation of applications and digital experiences, and help make those environments smarter, more efficient. We want to create those snap-in services that give you more visualization, better insights into that infrastructure, to secure that infrastructure in a simple and easy way, and be able to access that infrastructure simply via APIs. And we want that to be something that you can literally flip a switch on within your NGINX environment. We're standing behind some principles around that, and that is that this platform that we've built is all cloud native. It's fully managed, so you don't have to manage platforms, and it's available at all times. It's using modern interfaces with breakthrough UI design and is fully functioning API. And it's drawn upon our experience at NGINX and F5 as the leader in ADC services that sit in front of applications globally. The first solution that we want to bring and have brought to market and want to tell you about today is DNS as a service. We know that operating applications is very difficult, and especially at scale. DNS is really the first point of contact between the user and the application. And there's an opportunity to leverage that position in front of your application. So we've created a DNS service that is simple and easy to deploy, and it's a very effective way to manage the workloads across data centers by having a single point of presence on how you control DNS. This DNS service has the ability to protect the application as well from denial of service attacks. Both rate limiting and protocol intelligence of malformed DNS traffic can be blocked to reduce that service disruption that sometimes happens. And as we continue developing this service, we're building an NGINX integration which will take data from the availability, the network traffic, the load that's going across NGINX, being able to feed that into DNS and utilize that information to make more intelligent routing decisions for your customers. All of this is used very easy and simply accessed via an online UI. Also, an API can be used, and you can manage your entire global DNS infrastructure from this one console. The need behind managed DNS is threefold. One is that we're seeing more and more attacks every year against DNS infrastructure. And in the latest survey that is from IDC, we see 82% of organizations suffered some sort of DNS attack. We also know those experiences are so important. The speed at which a user can decide to go to your site or not could be 1 second. And if there is some delay, they may just abandon it altogether. So it's so critical that the DNS infrastructure is fast, efficient, performant for your users. And why it's vital is that as you build more of your application infrastructure in container environments or a more dynamic environment that is constantly evolving, constantly changing, auto-scaling, all of that needs to report and be integrated into your DNS infrastructure. DNS has to keep up with the massive changes that's happening within those modern infrastructure. We can keep up with this service, but we can also improve application performance by taking and ingesting, the load, the condition, the health of both the network and the application, and again, build that intelligence in to make split-second decisions on users that are actively using your app, moving them to the most available infrastructure or maybe even a different part of the globe. That was phase one, and that's available today. In phase two, we're building upon that platform and we'll be launching NGINX as a service, an analytics solution. This analytics solution will help you provide much more visibility into your NGINX environment by building not only the graphing and the visualizations around your network and application infrastructure, but also provide you the insights. And those insights will be utilized to make smarter recommendations for your NGINX configuration to make that environment more efficient, more performant, and more secure. So this is just a teaser. This is coming out soon, and we'll keep everyone of our audience engaged on what we're doing to continue this service going forward. And lastly, we're expanding the number of services that we're doing. We're working on new services that help you deliver ADC functionality, API management, and security in the future. And again, we'll keep everyone in the loop as we continue this journey forward in delivering new connected value to your NGINX infrastructure. With that, I want to say thank you for attending this NGINX as a service session. We have a demo of the DNS as a service, which will happen within the same link that you're using here. Please go check that out. And with that, thank you all for joining.
Hi, my name is Gene Kim, and I'm delighted to be here at the Sprint event for the next 3 days. I've been studying high-performing technology organizations since 1999. That's a journey that started back when I was a CTO and founder of a company called Tripwire in the information security and compliance space. And so our goal was to study these amazing organizations that had the best project due date performance in development, best operational stability and reliability in ops, as well as the best posture of security and compliance. And so we wanted to understand, how did these amazing organizations make their good to great transformation so that other organizations could replicate those amazing outcomes? And so you can imagine, in a 20-year journey like that, there are many surprises. But by far, the biggest surprise to me was how it took me in the middle of the DevOps movement, which I think is urgent and important. The last time we've seen any industry being disrupted to the extent that our industry is being disrupted today was likely manufacturing, when it was revolutionized through the application of the lean principles. And I think that's exactly what DevOps is. You take those same lean principles, apply them to the technology value stream that we work in every day, and you end up with these emergent patterns that allow organizations to do hundreds or even hundreds of thousands of deployments per day while preserving world-class reliability, security, and stability. So the Phoenix project came out in 2013, and after that we wrote the DevOps handbook, and here's a definition of DevOps that we used. It is the architectural practices, technical practices, and cultural norms that allow us to increase our ability to deliver applications and services quickly and safely. That enables rapid experimentation and innovation and the fastest possible delivery of value to our customers while ensuring world-class security, reliability, and stability. And so why do we care about that? It's so that we can win in the marketplace. So as much as I love that definition, because I haven't actually said what DevOps is, instead I've described all those outcomes that we aspire to. But there's a definition that I like even more than that, and it doesn't come from me. It comes from a friend of mine, John Smart. And when he was leading the Better Ways of Working at Barclays, which was founded in the year 1634, his definition that he used was this: it's better value, sooner, safer, and happier. I love it for so many reasons. One, it's shorter. Two, it is entirely as accurate as the definition that I gave you. And three, it's so hard to object to, because who wants worse value later, more dangerously, with more misery, right? So the fact that it is an aspiration that we can all get behind. And so what I've learned is that there are still some problems that remain, such as there is still this absence of understanding of all the invisible structures required to truly enable and unleash developer productivity. There's this orthogonal problem to DevOps that needs attention. So DevOps really pointed out that how difficult it was to get code to where it needed to go, which is in production, so that customers could get value. there's this other problem that exists, which is that data is often locked in systems of records and data warehouses, and it needs to get to the hands of developers and everyone in our businesses so they can make better decisions. But it takes weeks, months, or even quarters for it to get there. And that every time that we change a report, we might break 1,000 other reports. So it is too fraught with error. There's often strong opposition to support new ways of working, and often there's ambiguity in terms of what we need from our leaders to support this kind of transformation. And so in the Unicorn project, we use the 5 ideals. So in the Phoenix project, we had the 3 ways, the 4 types of work. The 5 ideals are meant to highlight 5 areas that I think are so important. One is locality and simplicity. The second is what I think the outcomes are: focus, flow, and joy. The 3rd ideal is improvement of daily work. The 4th ideal is psychological safety. And the 5th ideal is customer focus. So I'll go and describe for each one of these 5 ideals what ideal looks like and what the not ideals that so many of us are stuck in. But before I do that, I really want to talk about the value that DevOps creates. And so much of this was highlighted in the book Accelerate that I co-wrote with Dr. Nicole Forsgren and Jez Humble. And this is based on the State of DevOps report. So since 2013, over 6 years, we benchmarked over 35,000 respondents, really trying to understand what does high performance look like and what are the behaviors that lead to high performance. And what we found for 6 years in a row is that high performers exist and they massively outperform the non-high performing peers. As measured by what? We know that high performers are deploying more frequently. The high performers are deploying multiple times a day, so 2 orders of magnitude faster than their peers. More importantly, they have much lower deployment lead times. They can go from a change being put into version control, through integration, through testing, through deployment, so that customers are getting value. So that's 2 orders of magnitude more faster than the peers. But it's not just about agility, it's about the outcomes as well. When high performers do a production deployment, they're 7 times more likely to have it succeed without causing a 7-1 outage, a service impairment, a security breach, or a compliance failure. But when something goes wrong, which Murphy's Law guarantees, high performers can fix those issues in 1 hour or less. In other words, the mean time to restore service is 1 hour or less, 3 orders of magnitude more quickly than their peers. So what we found over 6 years is that they are more agile and they're also more reliable. And that's something that we've found year over year. We, over the years, looked at other outcome measures like security. We found that high performers were spending only 1/2 the amount of time remediating security issues because they were integrating security objectives into everyone's daily work. But even more important than these measures was something around organizational performance. We found that high performers also were twice as likely to exceed profitability, market share, and productivity goals. And for not-for-profits, same multiple. They were twice as likely to achieve organizational and mission goals, regardless of how they chose to measure it, whether it was customer satisfaction, quality, or quantity. And so the lesson is this: if mission achievement is reliant upon technology work, DevOps principles and patterns help with the achievement of those objectives. Other markers of organizational performance. Employees are twice as likely in high performers to recommend their organizations as a great place to work to their colleagues. And so the employee net promoter score is, there's a great deal of literature out there that shows its correlation to organizational growth and profitability. So what do all these numbers mean to me? It starts to paint a picture of what the opposite of technical debt is to what degree can we safely, quickly, reliably, and securely achieve all the goals, dreams, and aspirations of the organizations that we serve. So I mentioned the 5 ideals. Let's go to ideal number 1. So locality and simplicity. It really says to what degree are teams able to independently create value, to be able to develop, test, and deploy value to our customers that they want. So one of the biggest surprises for me was in the 2017 State of DevOps report, and it was around architecture. And this is such a surprise because 20 years ago, we were all trained that architectures could be ignored because they didn't impact how daily work was performed. And that is definitely, well, if that were ever the case, that's certainly not the case now, because what we found is that architecture is one of the top predictors of performance, even more than continuous integration and delivery. As measured by what? So to what degree can we make large-scale changes to our parts of the system without permission from anyone outside of our team? To what degree can we complete our work within the team without a lot of fine-grained communication coordination with people outside of our team? To what degree can we deploy and release our service on demand, independent of other services we depend upon? To what degree can we test on demand without using an integrated test environment? So all too often, we need to test in these environments that are never available. We always have to wait in line for months, and no one ever cleans them up, which actually jeopardizes the testing objective. So this is a point of coupling for us and the rest of the organization. And so if all those things are true, then we should be able to do deployments during normal business hours with negligible downtime. And so this is, again, one of the top predictors of performance. So we can boil it down to a measure. So in the Phoenix project, if there was one metric that measured the Phoenix project, it was the bus factor. In other words, how many people need to be hit by a bus before the project, service, or organization is in grave jeopardy. In the Phoenix project, the bus factor was 1. It was Brent, right? If Brent got hit by a bus, no outage could be fixed, no major piece of work could be completed without Brent. And so clearly we want a bus factor larger than 1. We need it. We don't want to be reliant on one person. We want to be reliant upon a team, or better yet, a team of teams. In the Unicorn project, the first ideal could be measured by the lunch factor. In other words, to get something important done, how many people do we need to take out to lunch? Is it the Amazonian ideal of the 2-pizza team, where every two-pizza team can independently create value for our customers without being reliant upon other people? Or do we need to feed everyone in the building? So think about a major complex deployment where we might have to feed 200 people or even 300 people, right? Because responsibility is scattered across so many different silos. Or do we have to take 43 different people out to lunch because we need something from them and they may never have heard of us? And any one of those 43 people, if they say no, we can't do what needs to get done. So ideal is that to get something done, we can implement what we need to by looking at one file, one module, one application, one container, and so forth. Not ideal is to make our need to change, we have to understand and change all the files, all the modules, all the applications, all the containers, right? So we've lost that locality, and again, we're coupled to everybody else. Ideal is when our changes can not only be implemented in isolation, but they can be tested in isolation, right? Isolated from all the other components. So in functional programming, we call that the notion of composability. Not ideal is in order to test the system, it has to be done in the presence of every other component. Again, drawing us back to that integrated test environment. In the ideal, every team not only has the expertise and capability to do what customers need us to do, but we also have the authority. Not ideal is that to make any decision, we have to go up to, over to, and then down to. So visually depicted, we have to go up to, over to, and down to. So friends of mine, they say this is the square. And so this is actually the good path. The bad path is we have to do the return path to allow 2 engineers to work together to do what the customer needs. One of the best books on this is the book Team of Teams by General Stanley Crystal, Chris Fussell, and Dave Silverman. And it is an amazing book that tells the story in a greater context, specifically around the Joint Special Forces Task Force in Iraq in 2004, where they were battling a far smaller, but far more nimbler adversary, specifically Al-Qaeda in Iraq. And they tell this amazing journey of how they're able to speed up decision-making, push decision-making down to the edge, bring authority to the information as opposed to information to the authority. I recommend this book to anyone that cares about this because there's so many lessons in that book. So first ideal is locality and simplicity. Second ideal is focus, flow, and joy. And so much of this was informed by me learning Clojure, the Clojure functional programming language that runs on the JVM or in JavaScript. It was the hardest thing I've ever learned, but it changed my life. It reintroduced the joy of programming back into my life. And so for 20 years, I primarily self-identified as an ops person. This was despite getting my graduate degree in compiler design in 1993. But I always gravitated towards ops because it was my observation that was ops where all the saves were made. It was ops who saved us from terrible developers who didn't care about quality. It was ops that protected our application data because it certainly wasn't information security. And yet, Clojure changed my mind. It showed me how fun development is and how you can build so many great things with so little effort these days. And so the French philosopher Claude Lévi-Strauss would say of certain tools, is it a good tool to think with? And I think functional programming and Clojure taught me and gave me better tools to think with, like immutability. And so immutability is core to many languages like Haskell, like Clojure, ReasonML, PureScript, but it's not just programming languages. You find immutability showing up in infrastructure and operation as well, because it helps us reason about and control complexity. And you see this in Docker. So Docker is all about immutability. If you want a lasting change to a container, you have to make a new one, right? Because local changes will get wiped out the next time you run that container. Kubernetes takes that to not just a component level, but the system or system of systems level. In fact, Kubernetes sidecars, which I found so baffling for so many years, suddenly made sense. The idea is that you can change a container without actually changing the application container. When you say something like Kafka or PubSub or message queues, that is often the desire of to create an immutable data model. And Git and version control in general is all about immutability. And that's why we get yelled at when we rewrite the commit history. So immutability is a better tool to think with, and it enables this ideal where our best time and energy is focused on solving the business problem and that we're having fun. Not ideal is that all our time and energy is spent solving problems that we don't even want to solve, like writing Kubernetes deployment YAML files or figuring out how to escape file names inside of makefiles or bash or writing ingress rules, right? And so what's so interesting to me is that there are a whole category of activities I used to enjoy doing a decade or two ago that I now detest doing. I hate doing anything outside of my application. I hate connecting anything to anything else because it always takes me a week. I barely know how to write CIDR blocks anymore. I hate updating dependencies. Secrets management. I'm the person who checks in secrets into the source code repos, often necessitating creating a whole new repo. Bash, YAML, patching. I can't get Kubernetes deployment files right on my first time. I can't understand my cloud costs are so high. And so I'm not intending to diminish these activities. In fact, these are important, and especially around security, right? Arguably, that is as important as the functionality that we as developers create. But I just don't like doing it anymore. And I think what rescues us is developer platforms. There's so many things we can do now through platforms because we are taking things like monitoring, deployment, environment creation, security scans, configuring firewalls, ingress and proxy, orchestration. All those things are now showing up in the platforms we use. So we can do them self-service, on demand, with a sense of immediacy and fast feedback, which I believe create the conditions for us to get a sense of focus and flow and even joy in our work. So I will make this claim that there has never been a better time to be in infrastructure and operations than now. And I would also add in security because we need all that expertise, not in their heads, but in the platforms they use, they create for us to use. And so to talk about flow, I would refer you to Dr. Mihaly Csikszentmihalyi. He's a cognitive psychologist, and he gave one of the best TED Talks of all time with the title of Flow, The Secret to Happiness. He describes a state of flow as being the sense of the feeling that we feel when we are so immersed in the work that we love, that we lose track of time, and maybe even sense of self, that transcendental experience that we have when we are doing the work that we love. And platforms, by taking away the things that we don't care about, allows us to focus, be productive, and enjoy our work. I keep screenshots of things that I don't ever want to Google for, like Java string decided write CIDR blocks and Java date times, right? Important, but not what I woke up in the morning to solve. So ideal is when we can do our work and implement what we need to and test the feature on our laptop and learn whether it works within seconds. Not ideal is that the only way we can determine whether this will work in production is by pushing production or waiting minutes, hours, days, or even weeks. So ideal number one is locality and simplicity. Second ideal is what the outcomes are, focus, flow, and joy. And the third ideal is improvement of daily work. So this showed up in the Phoenix project. And what it stated that improvement of daily work is even more important than daily work itself. So not ideal is twatty, the way we've always done it. right? So why change? That's not so good. What we want is the ideal, MTBTT, or better yet, make tomorrow better than today. That comes from Google SRE principle number 2. I think is almost poetic, right? We should all be striving to make tomorrow better than today. So what is not ideal? Probably the best example of this was the General Motors Fremont manufacturing plant before it turned into the site of the joint venture with Toyota and before it turned into a Tesla plant. This plant was notorious because for decades, it was not only the worst manufacturing plant in North America, but around the globe. There were so many instances because there were no effective procedures in place to detect problems through the assembly process, and because there were no explicit procedures on what to do when problems were found, there were so many instances of engines being put in backwards, cars missing steering wheels or tires, cars having to be towed off the assembly line because they wouldn't start. So this is clearly not ideal. What instead do we want? We want to create a system with as much feedback embedded into it, with from as many areas in the system as possible, where we can get feedback sooner, faster, cheaper, with as much clarity between cause and effect. And the reason for this is that the more assumptions we can invalidate, the more we learn. And the more we learn, the more that we can outcompete our competitors in the marketplace. So in 2011, I spent a week at the University of Michigan learning about the Toyota production system. And I got to learn about one of the most famous tools in the Lean toolkit, the Toyota Dandan cord. So this, of course, is what is on top of every work center in a Toyota plant, where if something goes wrong, we pull the cord. So if I manufacture a defective part, I pull the cord. If I get a defective part from someone else, I pull the cord. If I have no parts to work on, I pull the cord. I even pull the cord when the work takes longer than documented. So if it was supposed to take 55 seconds and it took 1:20, I pull the cord. So what happens when I pull the cord? If I can't resolve the issue in 55 seconds, the entire assembly line stops. So I knew that going into the training. What I didn't know was how many Dandan cord pulls per day there was in a Toyota plant. So just in your head, think how many Dandan cord pulls are there in a typical Toyota plant per day? And the answer is this, 3,500 pulls per day. And so my first reaction was, yeah, these people have no idea what they're doing, right? These guys are idiots, right? So why would I believe that? It's because we're taking a local disturbance and turning that into a global disturbance, which is very much the opposite of the way I was trained. I solve areas in my area of control before it causes a greater disturbance. So why do they do this? Why do they do something so disruptive so frequently? There are two answers they give, which I find very viscerally important. One is, if we don't put in a systemic fix then and there, technical debt accrues downstream or becomes far more expensive or maybe even impossible to fix. So that's interesting, but not as interesting as the second response. If we don't put in a systemic fix then and there, we're going to have the same problem 55 seconds later. And so that's the notion of a daily workaround. And so daily workarounds exist in our work as well, but because our work takes longer than 55 seconds, it is not as visible, but it is absolutely just as destructive. So again, that gets to my point that greatness is never free, right? We must create greatness, and we must do that through the paying down of technical debt. So let me tell you a story of how we create technical debt, where it comes from, and what we must do to eliminate it. And I'm going to tell the story only using up and down arrows. A friend once told me, when dealing with senior executives, stick with only small numbers and primary colors. But what I found in my journey was that often that's not sufficient. Stick with something even simpler, up and down. So here we go. Imagine a situation where we had to push to get to market. And so this is where the focus is all about features, either to be first to market, or when we're not first, we need to get into the market because we're last. And so when that happens, this is when we start cutting corners. We create technical debt, we build up risks. What that does is drive down quality. When quality goes down, the number of defects go up. So the story doesn't end there. If you go forward in time, what ends up happening is that the number of features that we can ship go down, right? Because the amount of time we're spending on defects go up, even to the point where our daily work is dominated by fixing defects, defects that escape into production. This is when site reliability tanks. This is when we go slower and slower. Customers leave, morale plunges, and engineers now leave because everything that used to be easy is now so hard. A friend tweeted this out at me. He said, exactly. Case in point, in 2015, a certain reference feature would take 15 to 30 days to implement. 3 years later, same class of feature now takes 10 times longer. And so if you've ever felt that this has happened to you, it's because it's true. And this happens despite adding more developers. So here is my favorite example of the risk of technical debt, and that is Nokia. So I mentioned Team of Teams. Here's the second book I would recommend to everybody, by Transforming Nokia by Risto Salasma. So he joined the Nokia board in 2008. And your first reaction is, what can we learn by someone who oversaw the decimation of 93% of the market cap of Nokia? And the answer is a lot. It is this unflinching look of his tenure at Nokia, and how they recovered afterwards. The best line is, in 2010, he described the scene when he learned from the VP of strategy that the build and test times for Symbian took 48 hours. He said when he learned that, it felt like being hit in the head with a sledgehammer, because he knew if it took 2 days for an engineer to learn whether the change worked or would have to be redone, all the hopes and dreams of that platform was an illusion, right? That it was doomed to fail. And that's actually what drove them to Windows Mobile, which didn't treat them so well either. But that was actually a better bet than staying on Symbian OS. And so Nokia didn't make it. But every organization that has gone through this has a different story, whether it's eBay, Microsoft, Google, Amazon, Twitter, LinkedIn, Etsy. They were almost all killed by technical debt as well, but they survived. So what did they all do differently? So I think the best example is Microsoft 2002. So this is right after the Summer of Worms, when SQL Slammer, Code Red, Nimda threatened to basically make sure that no one would use a Microsoft product because it was so prone to being taken down by external attackers. The countermeasure was so interesting. Bill Gates put out this trustworthy computing memo where they went on a security stand down. And they basically, every major product line stopped working on features. In fact, in this memo, he said, if a developer ever has to choose between working on a feature or fixing a security issue, you must always choose the security issue. And so this is what every one of those organizations did. They took feature rate down to 0 so they could pay down technical debt, so they could increase quality, so they could drive down the number of defects. Maybe not to 0, but something that was manageable on a regular ongoing basis. And what the result is that drove up developer productivity and the feature velocity orders of magnitude where they were before. And it's not just the CEOs. This comes from product owners as well. This is Marty Kagan. He's trained generations of product owners on how to build products that customers love. And his advice after going through a traumatic experience at eBay in the early 2000s as their VP of product management is that you must pay a 20% tax. You must take 20% of all DevOps cycles off the table to pay down technical debt. Because if you don't pay that 20% tax, you will invariably pay 100% tax. He did not ship a major feature at eBay for 2 years during his tenure at eBay. And so the only way to avoid that is to pay down technical debt as you go. So learning here is that in the ideal, 3 to 5% of the best engineers are working on improving developer productivity. Google has over 1,500 developers working on dev productivity, $1 billion of annual spend a year. Microsoft, even more than that. Not ideal. In most organizations, the only people working on dev productivity and platforms are summer interns and people not good enough to work on features. So in a wonderful story of karmic continuance, Satya Nadella, current CEO of Microsoft, says, in a town hall meeting last year, he said, if a developer ever has to choose between working on a feature or working on dev productivity, always choose dev productivity, because this is how we use compounding interest to our favor, as opposed to technical debt, which is very much to our detriment, or maybe to our destruction. So first ideal was locality and simplicity. Second ideal was focus, flow, and joy. Third ideal is improvement of daily work. Fourth ideal is psychological safety. So this we found in the State of DevOps report is that culture was one of the top predictors of performance. This is the Westrom organizational typology model. Dr. Ron Westrom in 2004 studied healthcare organizations, and he found that organizations with the best patient outcomes were highly correlated with very interesting cultural metrics. Those with the worst patient outcomes had these characteristics. We hide information. We shoot messengers who tell us bad news. We discourage bridging between teams. We cover up failures and new ideas are crushed. Whereas in the best patient outcomes, the organization exhibited these characteristics. We actively seek information. We train messengers to tell bad news, like in blameless postmortems. We bridge between teams, responsibilities are shared, because everyone knows that InfoSec is not just InfoSec's job, just like uptime is not just Ops' job, it is everybody's job. Failure causes a genuine sense of inquiry, and new ideas are welcomed. It was so fun researching the Unicorn Project because it made me revisit the work of Project Aristotle and Oxygen at Google. They spent years trying to learn what made the best teams the best. And year after year, the top factor was psychological safety, as measured by to what degree do people on a team feel safe to take risks, to say what they really think, without fear of ridicule or being made to feel embarrassed or being punished. That had a higher predictor of performance than dependability, structure and clarity, the meaning of work, or the impact of work. So in the DevOps community, we love talking about blameless postmortems or the exciting nature of chaos monkeys and game days where we deliberately inject faults into the production environment. But none of this is possible without psychological safety. So first ideal, locality and simplicity. Second ideal, focus, flow, and joy. Third ideal is improvement of daily work. And the fourth ideal is psychological safety. The fifth ideal is customer focus. Probably the best way to share what an aha moment this was when I got to visit the CEO of CompuWare for a day. So they're a famously resurgent mainframe vendor. And so I took a friend with, and I noticed while walking to the building that the first item up on the agenda was a data center tour. And I was immediately embarrassed. I was trying to explain to my friend, McKirsten, I'm sorry, I have no idea why we're getting a data center tour. I don't know what we'll learn by looking at their halon extinguishers. And yet, what I saw changed my life. It was like one of the biggest aha moments in my career because this is what I saw. Yes, you walk into a data center, but it was mainly empty. Yes, there were two Xeeve mainframes because they're a mainframe software vendor, but there was over 50,000 square feet of empty space. Instead, if you look on the floor, there's these green outlines, like in a murder scene of where the server racks used to be. And in the middle of each one of those outlines is a tombstone describing the application and the business process that used to be there, as well as how much money they saved by getting rid of it, moving it to a SaaS vendor. So EMEA financials, on-prem email, help desk, client backup, all these things gone. And so why is this important? Oh, and there's also this little sign that says over 14 tons of obsolete equipment removed and recycled, sent to a better place. So why is this important? Dr. Geoffrey Moore has this amazing book called Zone to Win, and he describes the notion of core versus context. Core is our core competencies, the things that create lasting, durable business advantage that customers are willing to pay us for. And context is everything else. So it might be mission critical, like payroll or like HR systems, like our ERP system, but customers don't pay us extra money just because we have great payroll services to our employees. So it's mission critical, but do not create lasting business advantage. So that CompuWare data center slide, what it shows is that by getting rid of all that stuff, they were able to reallocate $8 million from context and put it into core by investing into R&D, something that customers absolutely pay for. And so not ideal is when functional silo managers prioritize their silo goals over the grandest business goals. Ideal instead is when everybody, not just functional silo managers, but when we can unflinchingly look at the work we are doing in a given day and ask, is this creating genuine, lasting, durable business advantage? Is it part of core? And if it's not, it's part of context. And maybe we should start asking whether we should be doing it at all or moving that to a vendor where it is their core competency and that is what we pay for. So why do I think this is important? We are now entering the age of software and data where all of these things matter regardless of what industry we're in. But more importantly is this quote, the world is changing very fast. Big will not beat small anymore. Instead, it is fast beating the slow. And so in an age where we all need to be fast to survive and win in the marketplace, speed matters more than anything. And so the 5 ideals are really intended to frame things that we can do to help us work faster, safer, happier, so that we can win in the marketplace. It has been such a pleasure to be a part of Sprint Day One, and I look forward to spending the next 2 days with you, especially the amazing Day 3 of the hackathon, which I am so looking forward to. So if you're interested in any of the material, just email the NGINX team, and they can make this presentation available to you. And if you're interested in anything else, such as excerpts of and videos from the DevOps Enterprise Summit and other books I've written, just email realgenekim@sendyourslides.com. subject line DevOps, and you will get an automated response in the next minute or two. Thank you so much. I hope you've had a great day one, and I look forward to interacting with you over the next 2 days. Thank you so much.
That was great. Thank you so much, Gene. I, for one, am inspired to join the rebellion, and I just added the Unicorn Project to my local bookstore's digital shopping cart. Your perspective about the age of software reinforces for me what Gus was saying about how it's not just tools or technology, but a happy, healthy team that can contribute to or prevent innovation. So we're going to keep the conversation going now with the hallway track / Tech Field Day Roundtable. So stay tuned right here to watch live and ask questions and share your thoughts via the hashtag NGINX Sprint. The fun doesn't stop there though. Tomorrow, join us to watch our developers build, secure, and scale an application in real time. And on Thursday, we are closing the event with a Tech for Good hackathon. As we speak, teams are working hard on their Tech for Good projects using NGINX Unit. And then on Thursday, they'll pitch their apps and the winner will see their project funded. So thank you to AWS for partnering. Can't wait to see what y'all come up with. So thanks for tuning in. I'll see you tomorrow.